Flame. From Wikipedia, the free encyclopedia. For other uses, see flame, disambiguation. Flames of charcoal. Laminar flame of a burning candle. A flame, from Latin flamma, is the visible, gaseous part of a fire. It is caused by a highly exothermic reaction taking place in a thin zone. 1. Very hot flames are hot enough to have ionized gaseous components of sufficient density to be considered plasma. Fire, flames, may contain plasma, albeit one that is a partially ionized plasma, and dominated by collisions. Whether a plasma exists in a flame depends on the material being burned and the temperature. 1. The Contemporary Physics Education Project produces a poster on plasmas, see right, in which flames, fire, is shown as a plasma. In his book, Introduction to Plasma Physics and Controlled Fusion, Francis F. Chen notes, any ionized gas cannot be called a plasma. Of course, there is always a small degree of ionization in any gas. A useful definition is as follows: a plasma is a quasineutral gas, of charged and neutral particles, which exhibit collective behavior. He further goes on to describe three parameters that need to be satisfied in order to identify a plasma. These include the plasma approximation, bulk interactions, plasma frequency. In his book, Chen goes on to assess whether certain phenomena are indeed plasma, based on the three parameters, and concludes that a typical flame does indeed meet the criteria of being a plasma. In practice then, fire is a highly collisional, partially ionized plasma in which the collisions might mask some of the collective behavior. Flames as plasma. Alfred von Engel writes, the part of a flame that possesses the well-known properties of an electric plasma is called flame plasma, and thus not every type of flame deserves this distinction. Professor of Astronomy in the Physics and Astronomy Department at Tufts University, Kenneth Arlang writes, a candle flame is a plasma, as are all the stars in the universe. Imikia writes, a negatively charged sphere of a Van de Graaff generator attracts positive ions in the candle flame plasma. Although flame plasma normally moves upwards in the heated convection stream, it is pulled down towards the sphere as the heavy positive ions are attracted and pull all other components of the flame down with them, including low-density negatively charged components. See reference for illustration. Types of flame plasma. Alfred von Engel notes, there are special types of flame plasmas, such as plasmas in cool flames, or flames at lower pressure, which differ from what is commonly called a flame. Another types is the atomic flame, which is produced by an electric discharge. This is known to occur when a glow or arc discharge passes through a gas, whereby dissociation of the gas molecules takes place. In this way, atomic hydrogen, atomic oxygen and atomic nitrogen can be produced. The atomic hydrogen torch was first used for welding. Melting occurs not under the influence of the short arc flame, but due to the recombination of the hydrogen atoms to molecules on the surface, releasing an energy of approximately 100 kilocalories/mole or 4.5 eV. Another type of flames plasma is produced, for example, in rare of molecular gases, by applying large high-frequency ring discharge to the streaming gas. A flame of very hot, 10,000 to 12,000 K, excited gas emerges. Flame plasmas in electricity generation. Alfred von Engel writes, one of the current interests of flame plasmas in engineering problems is the magneto-hydrodynamic generation of electricity. Hydrocarbon flames are passed through a duct across which a strong magnetic field is applied. Electrodes perpendicular to the field and gas flow, but not necessarily opposite to one another, represent the poles of a generator which makes use of the principle of Faraday's dynamo, the copper wires being here substituted by a fast-moving ionized gas. 66. www.plasmauniverse.com web link. Next article. Ask a mathematician, ask a physicist. Physicist, generally speaking, by the time a gas is hot enough to be seen, it's a plasma. The big difference between regular gas and plasma is that in a plasma a fair fraction of the atoms are ionized. That is, the gas is so hot, and the atoms are slamming around so hard, that some of the electrons are given enough energy to, temporarily, escape their host atoms. The most important effect of this is that a plasma gains some electrical properties that a non-ionized gas doesn't have. It becomes conductive and it responds to electrical and magnetic fields. In fact, this is a great test for whether or not something is a plasma. For example, our Sun, or any star, is a miasma of incandescent plasma. One way to see this is to notice that the solar flares that leap from its surface are directed along the Sun's, generally twisted up and spotty, magnetic fields. We also see the conductance of plasma in toys like a Jacob's ladder. Spark gaps have the weird property that the higher the current, the more ionized the air in the gap, and the lower the resistance, more plasma equals more conductive. There are even scary machines built using this principle. Basically, in order for a material to be conductive there need to be charges in it that are free to move around. In metals those charges are shared by atoms. Electrons can move from one atom to the next. But in a plasma the material itself is free charges. Conductive almost by definition. As it happens, fire passes all these tests with flying colors. Fire is a genuine plasma. Maybe not the best plasma, or the most ionized plasma, but it does all right. Even small and relatively cool fires, like candle flames, respond strongly to electric fields and are even pretty conductive.